Hi everybody, today we are going to study about Regula Falsi method or the method of false position. The steps involving to find the real root of an equation f of x is equal to 0 by Regula Falsi methods are as follow. So this method is also used for to find the roots of real roots of an equation. Okay. So in that step first is choose any two trial points A and B such that f of A and f of B are of opposite sides. That means in bisection also we have studied same process. We have to choose two trial points such that f of A and f of B have opposite signs. This ensures that the graph y is equal to f of x crosses the x-axis and the root lies between A and B. Okay, from this we can say that it will be cut x-axis and the root lies between A and B. Okay, now consider the figure. Now here is the figure of the function y is equal to f of x. Okay, where here A is a point such that A comma f of A and here B is a point where B comma f of B. Now the perpendicular from B is a point B. Okay, and the perpendicular from A, this A is a point A comma f of A. That means here the distance, here this distance from A to capital A is a f of A. Okay, and here it is given f of B. Okay, and the function is of y is equal to f of x. Now by using equation of chord AB, this is a chord, we join this point A and B. This line is known as the chord of line AB. Okay, this arc AB. Now by a chord formula, equation of chord, you can say that y minus f of A upon f of B minus f of A is equal to x minus A upon B minus A. Okay, it is a difference, you may say a difference between 2 points also. Now we put y at initial or you can say that put y is equal to 0 and approximate root is obtained as, if you put y is equal to 0 in this equation, it will become after solving we will get x is equal to, we will write it as a first iteration x1 is equal to, the formula will be A into f of B minus B into f of A divided by f of B minus f of A. Okay, so this is our formula for a Newton-Raphson method. Here if f of x1 is 0, then x1 is the required root, otherwise we go to next step number 3. Now the root lies either in ax1 or x1b. That means you have to check if these are the 2 points A, B, and we will get somewhere here x1 in between A and B. Okay, so if it is a negative, it is a positive. Now it's depend on x1, we will have to consider the next interval. If it is positive, then our interval will be from A to x1, and if it is negative, it will be start from x1 and it will be end at B. Okay, so the value of f of x1 will be gives as next interval. Okay, so there will be 2 possibilities of interval, ax1 or x1b. Okay, now therefore either f of A and f of x1 have opposite signs, or f of x1 and f of B have opposite signs. Out of the intervals in ax1 or x1b, we take the interval at the end of which f of x is opposite signs, and we rename the interval as a1 b1. Okay, now after choosing the interval from these two, we rename this as a1 b1 or this as a1 b1. Okay, thus we obtain next approximation as x2 is equal to a1 into f of b1 minus b1 into f of a1 upon f of b1 minus f of a1. Okay, and if f of x2 is 0, then x2 is our required root, otherwise we will repeat this procedure till the root is found to the desired accuracy. Okay, so we have to repeat it again and again. If we repeat for x3, then the formula will be here, replace a1 by a2, f of b2 minus b2 f of a2 divided by f of b2 minus f of a2. Okay, this will be formula for next iteration. Okay, so we have to continue this process until we will get to a nearer value of 0. That means f will be nearer to 0 will be our approximate root of the given function. Okay, now we will go through examples of this point, method of false position or regular falsi method. Okay, now consider the example. Find the real root of the equation x into e raised to x minus 3 equal to 0 by regular falsi method, and we have to correct to up to 3 decimal places. Okay, now let f of x is given as x into e raised to x minus 3, okay, which is our function of x. Now we have f of we first find at rough calculation f of 0 is if you put x is equal to 0 in this equation, it will be 0 into e raised to 0 minus 3, which is equal to minus 3. Okay, for 1 f of 1 it will be 1 into e raised to 1, which is e minus 3, and you know that value of e is near about 2 point something, so its calculation will gives us minus 0.282, which is less than 0. Okay, and for this, for f of if we consider f of 1.1, because it is nearest value, so we take nearer approximately nearer to 0, so we will take 1 for 1.1, it will be 1.1 into e raised to 1.1 minus 3, and its calculation is 0.304, which is greater than 0. Okay, now here we will see the calculation. 1.1 into multiplied by shift e raised to it is again 1.1, which is equal to 3.30, and we have to subtract minus 3, so it will be equal to 0.3045, okay, which is a positive term, and at 1 it is e raised to 1 minus 3, okay, which is minus 0.2817, or you can write 282, which is less than 0. So our root will be lie in between 1 and 1.1. okay, we are taking nearest value about a 0 only, so therefore you can say that f of 1 is equal to, it is here directly calculate, minus 0.282, which is less than 0, and f of 1.1 is equal to 0.304, which is greater than 0. Therefore f of 1 and f of 1 and f of 1.1 is less than 0. That means root lies in interval or in between 1 and 1.1. okay, so here let we consider x0 is equal to 1 and x1 is equal to 1.1. Therefore x2 can be written as x1 minus x0 into f of x1 divided by f of x1 minus f of x0. okay, so here from you know the formula as x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a also. okay, so this term can be written as x1 is equal to a minus into bracket a minus b f of x1, sorry, here it is x1 minus x0, which is here, if you consider this as a and this as a p, you can write here it as a b minus a into f of x1, which is f of x1 is here also it is b minus, so we will write it again only, x1 is equal to b is x1 minus here x1 minus x0, which means b minus a into f of b divided by f of b minus f of a. Okay, f of x1 minus f of this are same formula. It is the easiest way to solve the example, so we will use this formula only. So here we have to consider a as a x0 and b as a x1, and we will go to our next iterations also. We will get next we will change the formula. So here value of x1 1.1. Here we have get f of 1 which is equal to f of x0, and it is f of x1. Okay, 0.304. So it will be 1.1 minus x1 minus x0, which is 1.1 minus 1, and f of x1 is 0.304 divided by f of x1 minus f of x0 is difference, so it is 0.304. Here it is multiplication sign, minus of 0.282. Okay, which will gives us 1.1 minus, it is a 0.1. We will do a calculation on Falsi here directly. 1.1 minus 1, which will 0.1, and we have to multiply it by 0.304 multiplied by 0.304. Okay, so it will be total value is 0.0304 divided by its calculation will be, now again denominator is 0.304 plus minus it will be plus, and 0.282, which is equal to 0.586. So on Falsi only we will calculate. The next step is 1.1 minus into bracket 0.0304 divided by 0.586. Okay, so here we get a value here answer is 1.0481, which is a value of x2, that means in interval, here it is interval 1 and 1.1. here it is functional value is f is negative and here it is positive. Okay, here f is less than 0 and at 1.1 it is greater than 0, and value of it will be 0481. it will be near where here 1.0481. now we will have to check the value of f of x2 is 0 or near negative or positive. Okay, so we can say that x2 is a root or not. Now f of x2 is equal to, it will be f of x2, our function is x into e raised to x, so x is 1.0481 into e raised to 1.0481 minus 3. Okay, so it will be, sir, here I will take it as an answer only in calculator, because here it is a value or 1.0481. we have taken here x2 into e raised to answer minus 3. So its calculation will gives us minus 0.0104. Okay, so which is less than 0, which is negative. So our next interval will be from 1.0481 to 1.1. Okay, so you can say that f of 1.1 into f of 1.0481 is less than 0. So root lies in interval 1.1 and 1.0481. Okay, now x naught will be equal to, so x naught here it will be 1 point here 1.0481 and x1 will be equal to 1.1. So our next iteration is x3 we will find, because here we find x2, so we will give formula as x3 is equal to, and we will take same formula as above only, x1 minus x naught into f of x1 divided by f of x1 minus f of x naught. Okay, and here value of f of x1 you must write here, because we have calculated above, f of 1.1 is 0.304 and this value will be of now f of x naught minus 0.0104. Okay, so x3 will be equal to, x1 is 1.1 minus x1 minus x naught is 1.1 minus 1.0481 into f of x1 is 0.304 and it's divided by 1.1 minus 1.0481, which will be equal to, so we will first find this value as a 1.1 minus 1.0481, which is equal to 0.0519. 0519, which is our denominator. Sorry, wait for a minute. Sorry, I have written wrong values here. Here it should be f of x1. F of x1 is 0.304 minus of minus f of x naught is a value here minus 0.0104. Okay, so here it will be changed. So here you can write, so we will first find the numerator. Here it is, numerator calculation is 1.1 minus 1.0481 multiplied by 0.304, so which is equal to 0. Numerator is 0.01577, or you may write here 576, here it is, so you may write 1578. Okay, and divided by, it will be 0.304 minus it will be plus 0.0104, so its calculation is 0.3144. so last calculation will be our 1.1 minus into bracket 0.01578 divided by 0.3144, which will be equal to 1.0498. 1.0498. Okay, now we have to check the value of 1.0498 is positive or not, at which is not nearer, now we have to check whether x3 is a root or not. That means it is 0 or it is negative or positive. So f of x3 will be, f of x3 will be 1.0498 into e raised to 1.0498 minus 3. Okay, so its calculation will be answer into e raised to answer minus 3. So its calculation, after calculation it will be look like here minus 5.8414 into 10 raised to minus 4. which means our calculation is near about a 0 value. So if we consider this, so it will be f of x3 will be minus 0 point. So we will write here minus 0 point how many? 10 raised to minus 4, which means we have to give 3 zeros after point. So 0.1, 2, 3. And after that we have to write this number 5841. So which is 5841, which is a less than 0, f of x3. Okay. So now here interval is from 1.1 to, it is interval from 1.1 to 1.0481. Here it is a negative, and here it was a positive. Now our next value is here near about here something 1.0498, and its value is negative. So here functional value we have taken only sign only. So our next interval will be in between these two. Therefore, sorry, I have written wrong again. Here it is 1.04981 and here it is 1.1, because at 1.1 it is positive. Okay, so here it is again negative 1.0498. So therefore f of 1.0498 and f of 1.1 have opposite sign, or you may write it is less than 0, opposite signs. Okay, so root lies in 1.1 and 1.0498. Okay, therefore consider x0 is equal to 1.0498 and x1 is equal to 1.1. Therefore x4 will be equal to, again formula will be same, x1 minus x0 into f of x1 divided by f of x1 minus f of x0. Here we write both the values. F of x0 is calculated here, it is minus 0.000581, and f of x1 is we have here taken as 0.304. So we will substitute here now 1.1 minus 1.1 minus 1.0498 into f of x1 is 0.304 divided by, so it will be divided by f of x1 is 0.304 minus of minus 0.0005841. So its calculation will be now, so 1.1 minus 1.0498 will be equal to 1.1 minus 0.0502 multiplied by 0.304 and divided by, so we will, here we will divide, multiplied again it by 0.304. We will decrease one step, so its calculation we will write it again. 1.1 minus his total calculation here, it is 0.01526 divided by, here denominator is 0.304 plus 0.0005841, which is equal to 0.30458. Okay, so when we divide 1 minus 1.1 minus into bracket 0.01526 divided by 0.30458, it will be equal to 1.04989. Okay, so x4 is equal to, now if you see the value of x3, we have solved it, it is x3 is 1.0498. okay, when we, after observation of x3, After point there are 3 or 4 digits same, x4 1.04989. Okay, so after point there are 4 digits same of these both x3 and x4. Therefore required root at end of third iteration is x is equal to 1.0499, okay, or 498. You may write here 8 also. Both are the correct answer. Okay, which is our required root, because in question we have given that correct to 3 decimal places. That means after point the roots will be same after 3 decimal places. So at x3 it is 1.049 and at x4 also it is 1.049. Up to 3 digits they are same, or up to 4 digit it is same. So we have a question, we have to correct up to 3 decimal places. So which is our required solution. Okay, so for homework you may solve an example with the same type. Homework, you have to solve e raised to x minus 4x is equal to 0, correct up to 3 decimal place. You have to find the root of this function f of x is equal to e raised to x minus 4x. Okay, so you have to, here we have to correct up to 3 decimal places. Okay, so you have to solve until you will not get the corrected 3 decimal places. Okay, you have to, I think here it is going up to 5th iteration. Okay, so this is your homework, you have to solve this. So for today we will stop here. In next lecture we will go to our next point. Thank you.